Welcome to our Introduction to Autodesk Inventor Professional 2010. If you've used previous versions of Inventor, the ribbon user interface might be new to you. The strip of commands near the top of the interface is called the ribbon. If you don't see the ribbon, click this arrow to toggle between its modes. Right now, if I click on it, the ribbon will minimize to panel tiles. Click again and it disappears, and I click a third time to restore the ribbon. Even though Autodesk Inventor 2010 introduces this new ribbon interface, you still have the option to select the classic user interface. Let's go to the Tools tab and then click on Application Options. From the Application Options dialog window, let's go to the Colors tab. Under Interface Style, we've got two options, Classic UI and Ribbon UI. UI stands for User Interface. Let's select the Classic User Interface and click Apply. And when we click Apply, Inventor is going to let us know that support for this interface is limited and that we're going to need to restart Inventor to apply the changes. I'm going to close this dialog window and pause my video while I restart Inventor. Welcome back. Here is the Inventor Classic interface. Now let's switch it back. We'll go to Tools, Application Options, the Colors tab again, and now let's switch to the Ribbon User Interface. Click Apply. Inventor lets us know that we'll need to restart the program again to apply the Ribbon User Interface. Let's close this window. I'm going to pause my video while I restart Inventor. Okay, welcome back. We're in the Ribbon UI again. Now, even though the classic user interface remains in Inventor 2010, there's really no guarantee that it'll be around in future versions of the software, so you might as well bite the bullet and figure out how to use the Ribbon user interface. Once I got used to the Ribbon UI, I found it much more convenient. That's because all of the tools from all the different environments in Inventor are very easily accessible without having to sort through different submenus and drop-down menus from the traditional Windows menu system. Some of Autodesk's other products already use the ribbon interface, such as AutoCAD 2009. In the subsequent chapters of this course, I'm going to be using the Ribbon UI to help you get used to it. And this concludes my introduction to Autodesk Inventor 2010. Welcome to our tutorial about Inventor 2010's user interface. As you see, I've only got 3 tabs available currently: Get Started, Tools, and Vault. Let's go to the Get Started tab. This is always a good place to start. I want to create a new file and I'm going to click on the New icon. Or I can click on this I icon, scroll down, select New. A drop-down menu for document types appears. I can choose a new file from an existing template, an assembly, drawing, part, or presentation file. Let's go ahead and click New. The New File dialog window opens. We can choose from these 7 templates. The files with extension .ipt are part files. We can choose a sheet metal part file or a standard part file. Files with the extension .iam are assembly files. We can choose between a standard or weldment assembly file. The .ipn template is a presentation file. .idw is a standard drawing file. .dwg, you might recognize this. This is an AutoCAD drawing file. We can also choose between English and metric units. Below, we define a project file. I'm going to talk about this in a little bit. There's a section down here called Quick Launch. It gives us the option to open a file. Let's click on it. The Open dialog window appears. Now in the Quick Launch section, you see that the Open option is grayed out. Let's click New now. It returns us to the New File dialog window. Let's open a standard.ipt template, that's a part file, and click OK. Right now we're in the Sketch environment. Sketch 1 has already been created for us. The document name, Part 1, is shown right at the top of the window. The Sketch tab is currently active. The ribbon displays a number of panels that relate to the Sketch environment. Draw, Constrain, Modify. Click the flyout arrow to see all of the available tools. You can pin down the flyout menu with this pin. To exit the Sketch environment, click this big green check mark called Finish Sketch. While I'm in the Sketch environment, if I click, for example, the Model tab, we can still see that the Sketch tab is active by its highlighted color. Do you remember the panel bar in previous versions of Inventor? Well, the ribbon basically replaces this. There's a number of convenient help tools that are easily available. When you mouse over a tool, a short help pop-up window appears. If I hover longer, an extended help pop-out appears with a description of how to use the tool and an example. I can also press F1 on the keyboard to read more about the tool. On the left side of our interface is what's called the browser with its familiar tree structure. It can be docked and undocked. At the bottom of the screen, we've got the status bar. Let's activate the line tool, and then we'll take a look at the status bar. It prompts me to select the start of the line or to drag off endpoint for a tangent arc. On the right-hand side of the status bar is a readout of the cursor's position in relation to the origin point. Let's try creating a line. Right-click and select Done when you're finished using a tool. The status bar lets us know that 4 dimensions are needed. To exit the sketch, let's click on the big green checkmark, Finish Sketch. We're now in the part modeling mode. On the top of the ribbon is what's called the Quick Access toolbar. When I mouse over an icon, Inventor lets me know what the icon does. This arrow here undoes the last action. If we click on it now, we'll go back to sketch mode, since that was our last action. Let's enter our sketch again. We'll double-click on the icon in the browser. Now let's go back to the Undo tool. When I mouse over it, the message has updated to undo our current last action, Start Sketching. Let's right-click on the Quick Access toolbar now. I want to check out some of the contextual menu options. From here, we can easily remove a command from the toolbar, add a separator, or show the Quick Access toolbar underneath the ribbon instead of on top. Here's my separator pipe. To remove that separator, right-click again and select Remove from the Quick Access toolbar. If I right-click on the ribbon, I see a contextual drop-down menu as well. From here, I can modify the ribbon appearance. For example, let's switch to Text Off. This compresses the panels a little bit. Let's turn the text back on. We can also minimize the ribbon. We can choose which panels to make available, set a docking position, etc. We're able to dock it top, left, and right. Let's right-click and return it to the top. You're also able to undock the ribbon and drag it freely around your workspace. Right-click and select Undock Ribbon. Now let's go to the Tools tab, Application Options, and to the Colors tab. Let's change the color scheme to Sky. Now let's go to the Part tab. Under Sketch on New Part Creation, we've got some options here. We've got Sketch on the XY plane selected. That's why when we created our new document, Sketch 1 was already established for us on the XY plane and active. Let's leave that option in place and click OK. The View Cube, the Steering Wheel, the Pan, Zoom, and Orbit tools, they all work the same as they did in Inventor 2009. We covered them in detail in our 2009 course, so please do refer to that if you need to refresh on those tools. This concludes our tutorial about the Autodesk Inventor 2010 interface. Welcome to our tutorial about creating a new project. Before creating a new project, let's close everything that we've got open. Let's go to the Close submenu. Select Close All. This closes all open files. Do we want to save changes to Part 1? No. First, we're going to specify the folder where we want all our projects to be saved. Let's go to the Tools menu, Application Options. Go to the File tab. Under the Projects folder, we can browse or specify the location of the project folder. Your project folder is where you're going to store all of your Inventor projects. Depending upon your situation, you might store your projects on a different drive than where the application is installed, or on a network or a server. I'm going to keep mine in my Z drive under Projects. It's pretty important to get your projects organized from the get-go. You'll find that very quickly you end up with hundreds of working files, and you and your colleagues might find it pretty frustrating if they're not well organized. At this point, let's click OK. Now let's go back to the Get Started tab. If you still have some documents open, let's close them, and now let's click New. Let's click Projects, and now go to the bottom of the window and click on New. Inventor's project wizard opens. What type of project are you creating? We want a new single user project. Click Next. Now we're prompted for the file name. The projects folder that we defined previously is pre-selected for us here. And let's enter a name for our project. We'll call our masterpiece My First Project. Notice that the project subfolder automatically takes the name of our project name. The project file's full path is named in the third line here. The project file is how Inventor organizes all the dependent files within any work project. And let's go to the next step in the wizard. Let's click Next. The wizard prompts us to add a library to our project if we wish to. For example, custom parts that we created earlier, or some standard parts such as bolts, nuts, washers, and so on that you might need for the project. At this point, we're ready to finish. Let's click Finish. Inventor prompts me, the project path you entered doesn't exist. Should it be created? Yes, let's create it. OK. My first project is now highlighted. I have some details down below. The project type, single user, the location, the folder and subfolder, and any included files. We don't have any included right now, so there's nothing listed here. In the top window, the current active project is marked with a black check mark. To make My First Project the active project, simply double-click on it. Inventor prompts us to save changes to our active project. Let's save them. And now My First Project is marked with a check mark and is the current active project. We can see our project subfolder and project file in the Windows browsing system. You may have noticed that there's another folder here called Old Versions that I didn't create. Well, Inventor made that folder for us. It helps us manage our files. Under Options, we see some old version specifications. Here we specify the number of previous saves to keep. In other words, how many backup versions you want to keep on file. I can keep 1, 2, or as many as I need. And your needs will vary by the complexity of your project and how frequently you update with your colleagues. Let's set the old versions to keep on save to 2. This means that I'd keep the current version, and then I'd also have saved in the old versions folder the last 2 saves. Let's leave it as 1 and go check it out. Click on Done. Right now, under the project file, My First Project is selected. Let's open the standard.ipt template. That's a part template, you might remember. Click OK. Now let's go ahead and save the file. Click on the disk icon. Inventor automatically navigates us to our project subfolder, My First Project. Let's accept the default name and type, and we're ready to click Save. Now let's go check out our project folder in the Windows directory system. Here's our new part file, and in old versions we've got nothing since we've only just saved once. Now let's create a simple sketch with a couple lines that'll give us something new to save. Right-click and select Done to exit the line tool. Now let's exit the sketch. We're ready to save again. And let's go back to our project folder. Let's go check out the old versions folder. I've got a file in here. That's the original file that I saved. As I mentioned previously, there's no standard number of backup files that you should keep. It really depends on the size of your project, the frequency of your collaboration with your colleagues, maybe the way you collaborate with them, and of course the reliability of your computer. If you find that your computer crashes frequently, you may definitely want to keep more backup files handy. This concludes our tutorial about creating a new project. Welcome to our tutorial about using constraints. I'm going to start by creating a new file. Let's stick with My First Project. We'll double-click on the part template standard.ipt. We're on the Sketch tab here, and first I'm going to begin by activating the Line tool. When I move the cursor close to the X or Y axes, you see this yellow point snaps to the axis, but it doesn't change color. Okay, let's create a simple line. Right-click and Done to close the line. The constraint between the line and the axis is not permanent. I can easily move the line by dragging it around. Let's create another line. If I create a line from the center point, that dot you see was green. Right-click and Done. I've created a permanent constraint. I'm not able to move this point. Let's create a couple more lines. Here's the parallel constraint symbol, and here's the perpendicular constraint symbol. Now when I start creating another line, I see the parallel glyphs between these two lines. Let's say I want this new line that I'm drawing to be parallel to the line above that starts at the origin point. What I would do is drag the cursor across that line. Let's catch it again. And the parallel glyphs appear. This means that the two lines displaying the glyph are parallel to each other. If I want my new line to be tied to this line back here, I drag my pointer along that line and we'll end up with a perpendicular relation between these two lines. Right-click and done. And let's right-click and select Show All Constraints. The shortcut key for that is F8, by the way. All my parallel and perpendicular constraints appear. Now let me create a line that's parallel to my previous line. See the parallel glyphs here? However, when I finish the line, right-click, done, I don't see this new parallel constraint displayed. We'll need to update. Right-click and Show All Constraints. And here the symbol is displayed. Right-click, Constraint Visibility. Here we can select which constraints we'd like to display by checking or unchecking their boxes. Apply and OK. Now I want to take a look at constraint options. They're available in the contextual menu. We right-click and select Constraint Options. From this dialog window, we can select which constraints are available for constraint interference. Let's uncheck Parallel and click OK. Now activate the Line tool again and create a line. Only the perpendicular constraint glyph appears, not the parallel glyph. That's because I unchecked it in the Constraint Options dialog window. Let's right-click and done. Now right-click Show All Constraints. Let's go back to the Constraint Options dialog window. This time I'm going to check Parallel. Under Scope of Constraint Interference, let's click Select. And let's select these two lines. OK. Let's activate the Line tool again. Let's create a line. The perpendicular glyph appears here. Let's look for the perpendicularity glyph. OK, when I scratch this line, the glyph appears. Let's try scratching the line underneath. No perpendicular glyph appears down here. Let's drop the line here. Right-click and done. And right-click back to Constraint Options. This time we'll check All Geometry. And click OK. Now let's go to the Tools tab, Application Options. On the Sketch tab, we've got an area labeled Constraint Placement Priority. Currently, the parallel and perpendicular option is selected. We can also choose horizontal and vertical. Let's cancel out of this window. And this concludes our tutorial about using constraints. Welcome to our tutorial about using the grid in Inventor. If you don't see the grid on your workspace, go to the Tools tab, click Application Options on the Options panel. Let's go to the Sketch tab. Under Display Area, check Grid Lines. If you like, check Minor Grid Lines. Let me cancel out of this window now. On our workspace, the thicker grid lines are the major lines. The thinner lines are the minor lines. Since we're working in inches, the grid is grouped by eighths. Let's select Zoom to Window. We'll make a selection of one of the quadrants. Let's go back to Application Options. On the Sketch tab, check Snap to Grid and click OK. Now let's create a few lines. Right-click and done. Here's our second line. And one more line. Let's snap again to this quadrant and then to this one. And right-click and done. Now let's dimension our three lines and the third line. Right-click and done. Here are three lines. The first line is 1 inch, the second is 1/8 of an inch, and the third is 3/8 of an inch. Let's go back to the Tools tab. This time choose Document Settings and to the Units tab. As I mentioned previously, we are working in inches. Let's go to the Sketch tab. Snap Spacing. Currently it's set to 1/16 of an inch. This value sets the snap point settings for the X and Y directions, and they can be different. Let's change the X direction value, let's say to 1/8 of an inch. OK. Now let's go to the Grid Display Control area. Here we can set the spacing between lines. The distance between the lines isn't set in inches, but in snaps. We can specify as well where we want the major lines to appear. Currently, the major lines are 8 minor lines apart. And we're ready to click OK and go back to our document. Let's zoom in a little bit more. And let's go back to Sketch and the Line tool. This little yellow dot near the cursor shows the snap point. It's every 1/8 of an inch in the X direction and every 1/16 of an inch in the Y direction. The way I've set this up might seem a little bit confusing, so let me adjust it a bit. We'll go back to the Tools tab and click on Document Settings. Now let's change the grid display to 1 snap per minor line instead of 2. Apply. Now we've got 1 snap per grid line here, or 1/8 in the X direction. While we've got the Document Settings dialog window open, let's change it back to 2. Apply. Now we've got 1 line for every 2 snap spaces, or every 1/4 of an inch. Let me move the Document Settings window so you can better see the workspace. Here we've got 4 lines now per inch instead of 8 lines per inch. Let's return to our original settings. Apply and close. And this concludes our tutorial about setting up the grid in Inventor. Welcome to our tutorial about the Select command. To select a simple entity, as you suspect, we can left-click on it. The circle is selected as indicated by the color change in my workspace. We're able to select more than one entity by holding down the Control or Shift keys and left-clicking. You are probably familiar with this from other software packages. To unselect everything, just click in the graphic area. A window selection from left to right only selects entities fully within the window. A window selection from right to left selects even the entities partially within the window. The window selection direction is also indicated by color, as you may have noticed. From left to right, the window is red with a solid line. And from right to left, the window is green with a red dashed line. Let's go ahead and select everything on our screen. Now let's say I want to deselect the circles. I hold down the Control key to deselect the circles one at a time with a left click. As an alternative, I can make a window selection from left to right and then deselect the rest of the circles. Knowing how to use the window select can save you a lot of time once you get used to it. And this concludes our tutorial about the Select command. Welcome to our tutorial about creating a profile. Let's start with a new document. OK. The document opens and Sketch 1 is active. Let's right-click and unselect Snap to Grid. Now let's activate the Circle tool. And we'll drop our circle about here. Finish the sketch. And let's go to the Model tab now. Activate the Extrude command. Since we've got a single closed profile in our sketch, it's pre-selected in the Extrude dialog window. Let's click OK. And now let's edit our sketch a little bit. Let's activate the Line tool. Create a couple lines, something like this. Right-click and done. Let's do 2 more lines. Right-click and done. Finish the sketch and back to the Model tab. Right-click on Extrusion 1, Edit Feature. There's a red cross displayed in the dialog window now. Let's click on it to examine profile problems. Inventor gives me a diagnosis. Open loop found in this profile. The problem profile is selected in our workspace. Let's click Next. Same problem with the second profile, an open loop. Let's cancel out of the Sketch Doctor and cancel out of the Extrude tool. Double-click on Sketch 1. Let's go fix our problems. We'll activate the Trim tool. Let's trim these corners and then finish the sketch. Back to Extrusion 1. Right-click, Edit Feature. The Sketch Doctor's red cross icon is no longer displayed. That means that we fixed our problem. Let's click on Profile. We're able to select the second profile now. Basically now we've got two closed loops, and we can use these to create solids. Let's double-click on the sketch now. We'll make some more changes. When we used the Trim tool, Inventor added a coincident relation to all four corners. Let's right-click and show constraints. We see the coincident constraint when I mouse over the corner. Let's go ahead and select and delete the constraint. Now if I exit the sketch, we're going to get an error message because our profile is now open. Let's close this profile. We'll grab and drag the point over this point and drop it when the point becomes green. The coincident relation is back in place. Let's update the Show All Constraints to make sure. Right-click, Show All Constraints, or F8. Here is the coincident relation displayed. Let's select and delete this circle and exit the sketch. We get a warning message. Errors occurred during the update. The profile loop couldn't be repaired. The extrusion couldn't be built. Our solution? We'll need to edit Extrusion 1 and reselect the profile. Let's accept that suggestion. We'll double-click on Extrusion 1. Select the profile. It's the only one here. Now let's go to the More tab. Let's apply a -5-degree taper. The arrow here indicates the direction of the taper. Let's click OK. Now I'm going to create another sketch. Let's right-click on a profile, New Sketch. Select View Face, and I'll select this face. Our projection geometry is already created here. Let's create some more projection geometry. We'll select these four outer lines. Right-click and done. Here we've got two closed profiles. The geometry is fully constrained. Let's right-click and Show All Constraints. Looks good. Let's finish the sketch. Activate the Extrude tool. Here we can select one or two profiles. Cancel out of the tool and double-click on Sketch 2. Let's add a couple more lines. Something like this. Right-click and done. And another line, right-click and done. Now let's activate the Trim tool and we'll trim these ends off. Right-click and done. Right-click, Show All Constraints. As you see, the Trim tool automatically added coincident constraints. Let's finish this sketch. Activate the Extrude command. We've got 5 closed profiles here. What if I want to select the profile that's between these 4 lines? Cancel out of the tool and double-click on Sketch 2. Now let's drop a point right about here. Right-click and done. So let's apply a coincident constraint. We'll select this line and this point, this line and the point. Right-click and done. Show All Constraints. And here is our coincident constraint. In the status bar, we're prompted for 4 dimensions. Let's activate the Dimension tool. Right-click and done. Or I can use a fixed constraint. I can fix these 4 lines. Now we've got a fully defined sketch, blue in color. Let's right-click, select Done. Let me show you how the fixed constraint works in a moment. For now though, let's go back to the Model tab, exit the sketch, activate the Extrude tool. Now I'm able to select the profile in this corner. Let's cancel out of the tool and go back to our sketch. If I try to trim the projected line, I can't do it. In order to do so, let's right-click and done. I need to delete the projected geometry constraint. Activate the Trim tool. Now when I try to trim this line, I get an error message. Adding this constraint will over-constrain the sketch. Let's cancel out of the warning message. Right-click and done. The reason for this is because I have this line dimensioned. If I delete the dimension, I'm able to trim the line. Right-click and done. We need to add 2 more dimensions. Let's click on the fixed constraint. We'll select this point. Now the sketch is fully constrained. Let me show you now how the fixed constraint works. Let's draw a line. Right-click, done. This line has got 3 degrees of freedom. I can drag it in the Y and X directions, and I'm also able to grab and rotate if I select and drag at the end. Let's select Fixed, and then select the line. Right-click and done. This action has fixed the angle and line direction. The endpoints can still be moved. Let's add some dimensions now. One dimension is needed per the status bar's message. The status bar still tells us that 1 dimension is needed. Right-click and done. I can still move the line. Let's add 1 more fixed constraint. And the line is fully constrained. Right-click, done. Right-click, show all constraints. Okay, let's delete the constraints. Now let's add a fixed constraint to the midpoint of this line. Right-click and done. Now the line can be rotated along the midpoint. And that's all I wanted to show you about how the fixed constraint works. This concludes our tutorial about creating profiles. Welcome to our tutorial about sharing sketches. I've already got Sketch 1 active. I'm going to select the Circle tool now. And let's drop a circle right around here. The center is the origin point. Let's activate the Line tool. We'll snap to the first point of the circle and to the second point. We still have the Line tool active. Let's mouse over until we get the green dot and snap to this point on the circle. And let's close our triangle where we started. Right-click and done. Let's add an equal constraint. This line will be equal to this one, and this line equal to this one. Okay, that looks better. Right-click and done. Let's apply some dimensions now. First we'll do the circle. We'll give it a diameter of 1.5 inches. Okay. 1 dimension is still needed. Right-click, done. Basically, the triangle can rotate inside the circle. Let's apply 1 more dimension. We'll select this point here and the center point. Let's place the dimension right here. Let's enter 0 for the value and click OK. Our sketch is fully constrained. Let's undo those last 2 dimensions. There's another way to place a dimension if in fact I want to constrain my sketch using dimensions. We can use a horizontal dimension. Select the line instead of the point. And this point, the center point. Let's use a horizontal dimension. Click the diameter dimension, divide it by 2. OK. Finish our sketch. And we're on the Model tab. Let's activate the Extrude command. Let's select this profile here. Actually, let's use the Revolve tool instead. Okay, we'll select this profile, the axis, this one. Okay. Now to reuse this sketch, you right-click on it and select Share Sketch. Activate the Revolve command. I'll use this profile and this axis. And revolve again. This time we'll use this profile and this axis. OK. Extends, full again, and OK. Last one, activate the Extrude command this time. We'll select the triangle. We'll cut in both directions. Extends. Let's use All. And click OK. Let's make one more example. I'm going to Shift-select everything and right-click, delete it. Now let's right-click on Sketch 1 and delete it. I'm going to create another sketch on the XZ plane. Let's start with a rectangle. Something like this. Right-click and done. We'll apply some dimensions now. 1.5 inches. OK. And let's make this dimension 2.5 inches. OK. Right-click and done. Now let's use the Offset tool. We'll select the rectangle, select Inside, right-click and done. And let's select this line. Click Delete. Now let's activate the Extends tool. Click this line and this line. Right-click and done. Let's apply some dimensions now. Between this line and this line, we'll have a distance of 1/8 of an inch. OK. And this line and this line, also 1/8 of an inch. OK. And between these two lines, also the same. OK, now our sketch is fully constrained. Let's exit the sketch. And let's activate the Extrude command. I'm going to select this profile and this profile. Now let's enter a distance of 1/8 of an inch. And OK. Let's expand Extrusion 2, right-click on Sketch 2 and select Share Sketch. Now let's activate the Extrude command again. We'll select this profile. Our distance, 1/2 an inch. Click OK. And this concludes our tutorial about sharing a sketch. Welcome to our tutorial about center lines. In this tutorial, we're going to look at the difference between regular lines, construction lines, and center lines. Let's begin by creating a shape. Activate the Line tool. Something like this. Now let's create a vertical line somewhere here. Right-click, done. Finish sketch. Now let's activate the Revolve command. Inventor asks me to select a profile and then the axis. Let's cancel out of the tool. Double-click on the sketch. Select the sketch. Let's change the sketch to construction geometry. Let's exit the sketch again. And I'm going to apply the Revolve command again. Since we only have one closed profile, Inventor recognizes this profile automatically, but Inventor asks me to select the axis. So let's select this line as our axis. And let's cancel out of the tool now. OK, let's double-click on Sketch 1. Now let's apply some dimensions. I want to put a dimension between this construction line and this line. You see that we've got a regular linear dimension now. OK. Right-click, done. Let's select and delete this dimension. Now let's select this line. We're going to convert it to a center line. Let's apply dimensions again. Now Inventor gives me a diameter dimension. And that's because, let's click OK, Inventor has recognized that I'm measuring the distance between the center line and the end line. Let's exit the sketch, finish sketch, activate the revolve command again. Inventor automatically recognizes the profile and the axis. All we have to do is click OK. And here is our revolution. This concludes our tutorial about center lines. Welcome to our tutorial about creating a rectangular pattern. I've split this chapter into 2 videos. For a basic overview of the rectangular pattern tool, please see volume 1 of this course. Here we're going to use the rectangular pattern tool in more depth. Let's begin by creating a sketch. We'll need a rectangle somewhere here. Let's add a 3-point arc. Here's the first point, the second point, and point number 3. The 3-point arc tool is still active. Let's create another arc. The tangency symbol appears between the arcs. Let's right-click and done. Now I'm going to select this line and convert it to construction geometry. Next, let's select the coincident constraint. Select this point and this line. Since we have a tangency constraint between the arcs, the second arc adjusted as well. Right-click, done. Now let's apply some dimensions. Activate the dimension tool. 1.5 inches. OK. And the second dimension, let's make it 3 inches. OK. By the way, if the Edit Dimension dialog window doesn't appear when you create a dimension, go to Application Options and the Sketch tab. You need to enable Edit Dimension when created. OK, let's cancel out of this dialog window. And back to the Sketch tab. We see in our status bar that 2 more dimensions are needed here. Let's use a coincident constraint between this point and the center point. Right-click, done. Now I've got a fully constrained sketch. Let's exit the sketch, finish sketch, over to the Extrude command. The profile is automatically pre-selected. Extents, let's enter a distance value of 1/8 of an inch, 0.125. OK. Next, I'm going to create a rectangular hole. Right-click and New Sketch. Let's drop a line between the center of the arcs. Right-click, done. Activate the Rectangle tool. And let's place our rectangle right about here. Right-click, done. Let's convert our new line to construction geometry. And let's dimension the rectangle. We'll make this dimension 1/8 of an inch, 0.125. OK. Let's make the second dimension 3/8 of an inch, 0.375. OK. And let's apply a coincident constraint between this point and this construction line. Right-click, done. We need 1 more line here. Activate the Line tool. Right-click, done. Let's convert this to construction geometry. Add 1 more dimension between this point and, oops, I need a point here. Let's add a point. There we go. Okay, let's apply some dimensions between this point and the center of our rectangle. Let's make this distance 0.9531. OK. Our sketch is fully constrained. Let's exit the sketch, finish sketch, activate the Extrude command now. For the profile to select, let's get our rectangle. Cut. Extents. Let's use All. Click OK. Now let's activate the Rectangular Pattern tool. Let's select a feature. Extrusion 2. Direction. We'll select this edge. We can reverse the direction if needed by clicking that icon. I want to orient my pattern along this line. Let's select direction 1. Number of instances, I'll use 5. Now let's look at some of the different options on this window for distributing our pattern along this line. Currently, we've got spacing selected with a value of 1 inch. This means that each instance is going to be 1 inch apart along this line. Let's take a look at the next option, distance. And here we need to enter a value. Let's put 4 inches. The last option is curve length. Now you see that the value box is grayed out. The length displayed there, 4.712, is the actual length of that curve. If we go back to distance, we're able to make an entry in this value box. Let's say that I want to place 5 instances along that value. I can enter a formula. Enter the divide symbol and 4. Basically, we've got 5 instances, but 4 spaces between them. Let's remember that value now, 4.712, and let's click OK. Now let's say I want to use the same feature, and I'm going to create a pattern along a different edge, let's say down this edge. Activate the rectangular pattern tool. Now select the feature, Extrusion 2. Direction, we'll use this edge this time. Let's click these arrows to expand the rectangular pattern window. Under Orientation, let's choose Direction 1. Number of instances, let's use 5 again. We'll use the same spacing as in the previous example, 4.712, divided by 4. Well, as you can see down below, we obviously have a problem. In addition to the fact that the pattern goes off the edge of the plate, the distance between the instances is larger than in our previous example. The reason for this is pretty simple. The instance is further from the center of our new circular edge than the source was from the center of the previous circular edge. If we want the pattern to match up, we're going to need to do it a little differently. Let's cancel out of the rectangular pattern tool. Let's say I want to create 4 more instances of this hole distributed here at an angular distance of 90 degrees. Let's begin by creating another sketch. Right-click, New Sketch. We'll start by creating a couple of construction lines. Here to this point, from this point to this point. Right-click and done. Actually, let's create one more construction line from this corner to this corner. Right-click, done. Let me just zoom in a little bit. Okay, let's activate the 3-point arc tool. We'll select this point and a point somewhere along the construction line. Let's drop it right there. Right-click, done. We'll apply a coincident relation. This point and this point. Right-click, done. Let's create a second arc now. First point, second point. Point number 3, right-click and done. And let's add a coincident relation between this point and this point. Right-click, done. As you can see in the status bar, the sketch is fully defined, so let's click Finish Sketch. Now let's delete this rectangular pattern. Right-click and delete. Let's activate the rectangular pattern tool again. The first thing to do, our feature to pattern. Direction 1, this sketch, expand. Orientation, direction 1. We want 5 instances. Let's choose curve length. Distribute it along this arc. As you can see, the length of the arc is 2.994 inches. Let's remember this number and click OK. Now right-click. Let's bring in Sketch 3. Right-click, Visibility. And let's activate the rectangular pattern tool again. Select the same feature. Direction 1, this line. Orientation, direction 1. Number of instances, 5. and distribute it along the length of this curve. Okay, not bad. The distribution is a lot more even than our previous example. But we still do have a problem because the curve length we used previously was 2.994, and here we can see that the length of this curve is 3.215. Let's click OK. Let's see how we can solve this problem and make both of these arcs equal in length. In order to do so, we're going to need to refresh some of our basic geometry. We'll be using a formula. The circumference of a circle is equal to pi multiplied by the diameter. Since the first arc in our case is 180 degrees and the second arc is 90 degrees, the first circumference is equal to the second circumference as I've represented in my formula on our workspace. Since pi is a constant in our equation, the radius of the first arc equals the radius of the second arc divided by 2. Since the distance between these 2 points is 3, it means the first arc has a radius of 1 inch, and the second arc needs to have a 2-inch radius. Geometry and algebra, folks. Let's go back to Extrusion 2, double-click on Sketch 2. Let's change this distance. Enter 1 inch. OK. Finish sketch. Now let's go to check pattern 1. The length of our curve displays as 3.142. OK. Let's check the second rectangular pattern now. Again, same thing, 3.142 inches. And this concludes our first tutorial on the rectangular pattern tool. In our next chapter on this tool, we're going to be covering some of the additional options on the dialog window. Welcome to our second tutorial on the rectangular pattern tool. In this tutorial, we're going to take a closer look at the compute option on the rectangular pattern dialog window. We're in Sketch 1. Let's begin by creating a shape. And let's close our profile, right-click, done. Now let's apply some dimensions. For this dimension, 1.5 inches. OK. Let's make this side 0.125. And this side 3/8 of an inch. OK. And lastly, this segment will be 1/2 an inch. OK. Let's exit the sketch, activate the Extrude tool. 1 inch. OK. And let's create a second sketch. Select. Let's take a top view. Now activate the circle tool. Let's drop our circle right about here. Right-click, done. Now let's right-click and select Slice Graphic. Let's dimension the circle. The diameter will be 1/8 of an inch. OK. And let's apply a second dimension also 1/8 of an inch. OK. Let's exit the sketch. And we're going to create a hole with the Extrude tool. Let's select this profile. Distance. Let's enter 1/4 of an inch. Let's take a side view and click OK. Now activate the rectangular pattern tool. Under Features, let's select Extrusion 2. Direction 1, this line. Now for the spacing. Let's make it 1/4 of an inch. Under Compute, I'm going to select Optimized. Click OK. Let's double-click on our rectangular pattern feature in the browser. Expand. Basically, the Optimized option copies the faces of the pattern feature. That's the fastest computing method. But there are some limitations. Let's check those out. If I try to overlap the pattern feature, for example, I'll get an error message. The occurrences failed to execute. Let's click Edit. Let's try it out with the identical compute option. Click OK, and we have no problem. Okay, let's double-click on the rectangular pattern feature again. Just like its name indicates, the identical option basically creates a feature by replicating the original feature. To demonstrate, let's offset by 7/8 of an inch. You'll notice that we don't see the preview now. Let's click OK. Now let's go to the View tab, and we'll select Hidden Edges. Since our original hole was 1/4 inch in depth, the second hole doesn't go through. Well, let's take a moment to fix that now. We'll double-click on Extrusion 2 and make some edits. Under Extents, let's select All this time. Click OK. And now you see that we've got two identical holes. Let's double-click on our rectangular pattern again. Back to Compute, we're going to select the Adjust option this time. This option rescales the distance where the feature terminates. This option is the most CPU intensive. Let's try it out. Click OK. And here is our second hole. The load on the CPU is something to consider when you've got a very complex pattern. This concludes our second tutorial on the rectangular pattern tool. Welcome to our tutorial about the circular pattern tool. In this tutorial, we're going to take a look at sketch patterns and feature patterns. Let's begin by shift-selecting both rectangular patterns. I want to get rid of those. Let's right-click and delete. Now let's activate the circular pattern tool. It's up here. First, we need a feature to pattern. Let's choose Extrusion 2. Now we need an axis. Let's select this cylindrical face. Placement, number of instances, 5. Degrees of rotation, 180. And we're ready to click OK. Let's activate the tool again. For the feature to pattern, select Extrusion 2 and this cylindrical face. 90 degrees. 5 instances. Let's click OK. We've achieved the same results as in our previous tutorial on the rectangular pattern tool. Okay, let's shift-select everything, right-click and delete it. Now let's right-click and suppress Extrusion 2. Right-click, New Sketch. Let's take a front view and activate the Line tool. I'm going to start by creating a construction line. Right-click, Done. Now let's add some dimensions. Activate the Dimension tool. The line will be 1 inch long. OK. Right-click and Done. And I'm going to place a point right here. Right-click, Done. Let's activate the Circular Pattern tool again. Under Geometry to Pattern, I'll select this point. The axis, let's make it this circular line. Number of instances, 5. Degrees of rotation, let's enter 180. Reverse the direction. And we're ready to click OK. Let's exit our sketch. Now let's activate the Hole command. Under Placement, let's choose From Sketch. The holes are already pre-selected on our drawing. Let's use a simple drilled hole for this example. Click OK. Now let's right-click and edit the sketch. Right-click on any one of the points and select Edit Pattern. Let's use 6 instances over a 360-degree distribution. OK. And finish the sketch. As you may be noticing, we've got one hole missing. Let's go fix that. Right-click, Edit Feature. Let's select this point and click OK. All right, let's delete hole 1 and delete the sketch as well. Now let's create a new sketch. Right-click, New Sketch, Activate the Line tool. Right-click, Done. Now let's dimension the line. It's going to be 1 inch. OK. And let's exit the sketch. Now we're ready to activate the Hole command. Placement from Sketch. I'm going to use this point and click OK. Let's take a home view. Activate the Circular Pattern tool. Feature to Pattern. Let's choose Hole 2. For the axis, let's select this cylindrical face. Number of instances 6, distributed along 360 degrees. Click OK. As you can see, there's plenty more than one way to build something in Inventor. The more comfortable you are with the tools, the more flexibility you'll have in determining which methods work best for your projects. This concludes our tutorial about the Circular Pattern tool. Welcome to our tutorial about hole placement. First, let's create a sketch. Something like this. And let's close our profile. Right-click, Done. Let's apply an equal relation here. Right-click, Done. And let's apply some dimensions. This one will be 1/2 inch. The angle here, let's make it 150 degrees. And click OK. Now we're ready to exit the sketch. Activate the Extrude command. Extents, distance, 2 inches, and OK. Let's take a home view. Now let's create one more sketch. Right-click, New Sketch. Let's activate the Point tool. Drop our point about here. Let's dimension the position of this point now. We'll make it 1/2 inch from this edge. OK. And 1/2 inch from this edge as well. OK. Let's exit the sketch. Now we'll activate the Hole command. Currently, the only available placement option is from Sketch. With this option, you can create a hole that's normal to the sketch. Let's cancel out of the Hole command dialog window for now, and let's explore how we can create a hole at a different angle. I've selected Work Point. I'm going to place it right here. Let's go back to the Hole command. Now we can select the On Point placement option. Then I'll select this point and this edge. The rest of the options we'll leave as is and click OK. As you see, we obviously have a problem. Let's view this in wireframe mode. View, Wireframe. We can solve this problem in 2 ways. One, I'll create a sketch right here. Finish the sketch. Extrude. Extruded Cut. Select Other. And OK. Now let's go back to Shaded View. And here is our hole. OK, let's delete Extrusion 2 and Hole 1. Click OK to remove the sketches as well. Now I'm going to create an axis that goes through this point parallel to this edge. What I want to do here is create a point along this axis that's 1/2 inch from this point. I'll be using a grounded point. Okay, let's select this point. The triad appears. Let's click Redefine. We'll select this axis and this work axis. Now select the axis again. Let's type 0.5. Apply and OK. Let's take a minute to show how grounded points work. A grounded point isn't tied to any geometry. Let's check it out. I can grab the center of the triad and drag it around freely. I can also select a triad plane and drag those around. I'm able to select an axis and rotate it. Let's say 45 degrees. Apply. If I click the arrow, I'll be able to move the triad in the X direction. To reorient the triad axis, simply click Realign. Let's select this axis and this edge. Okay, let's cancel out of this tool. Let's return to our hole now. We'll activate the hole command. Select On Point from the Placement drop-down menu. Select this point and this work axis for our direction. As you can see, the hole now originates above the drilled face. If you want to have a 1-inch deep hole, you need to add half an inch to compensate for the offset of the origination point. Let's go ahead and click OK. And let's place one more hole. We'll put it on the midpoint of this edge. Let's activate the hole command again. This time we'll use a countersink hole. From the Placement drop-down menu, we can choose On Point. We'll select our point. For direction, let's use this work axis. Here's our preview in red outline. Let's click OK. Uh-oh, we don't see the hole at all. Let's go to wireframe mode to understand what's going on. Let's make some changes to our sketch. Select this face. There we go. And finish the sketch. Now activate the Extrude command. Let's select this profile and this one. Extruded cut. Let's reverse the direction. Click OK. Let's go back to shaded view. And lastly, let's create a new sketch. I want to show you one more thing. Let's activate the line tool. Place a line right about here, right-click, done. Let's make it a construction line. We'll apply some dimensions. Let's say it'll be at 50 degrees. OK. Finish the sketch. Now let's place a work point. There we go. And activate the hole command. Placement. Actually, let me cancel out of the hole command for a moment. I need to create a work axis based on this sketch. Okay, now we can activate the hole command. Placement, On Point. Select our point, axis, reverse direction, and click OK. As you can see, we're not able to select a sketch line for a direction, but we're able to create a working axis from it and use that instead. And this concludes our tutorial about hole placement.